Hey, Bill.
Hello, Kat.
So you are going to demystify brew pressure release.
Pressure release for brewing, correct.
Yes.
Not to be confused with overpressure valve, pressure relief valve.
Okay.
The other assorted oddities.
Why don't you give us a quick rundown of the difference between those?
Okay, so typically, if a machine has a steam boiler, there will be some kind of overpressure valve that releases at some point greater than what you normally use the steam boiler at. So let's take, for example, a steam boiler running at 1.5 bar. Sometimes the pressure relief valve will go at 1.8 or 2 bar.
Okay.
It just avoids if you have a runaway heating element that stays on all the time. If the water inside boils too much, that won't create too much pressure inside, and it will release the pressure inside the steam boiler.
Do we have one? I know we have a boiler over here. Do we have a visible one you could show what that looks like?
There's not, but I can show. There's one right here.
In our cleaning solution.
Right. Here's a couple overpressure valves.
Okay.
These ones are made by a company in Italy, and they have a seal on here that they're set to a particular amount, and these ones are set to, of course, these ones are 2.5 bar.
Okay. For whatever. So that it's just sort of a safety mechanism, so basically your boiler doesn't explode.
That is a safety mechanism for sure.
Okay. All right.
All right. And then there is a pressure relief valve for the brew boiler, or we call them overpressure valve for some of the home machines that use a vibrating pump.
Okay.
And what that does is it limits the pressure that the coffee sees when it's brewing. So on a home machine that has a vibrating pump, the vibrating pumps are rated to about 12 bar, give or take, a couple bars, between 11 and 15 bar, depending on the manufacturer. So, and that's the only way they can achieve the proper flow for the coffee. So essentially, you don't want to brew at that high rate. So we have what's called an overpressure valve, which limits the maximum pressure that the coffee will see at any time.
Okay.
So, and an overpressure valve, when the pump pumps at 12 bar, when the coffee builds up pressure at up to 9 bar, let's say the overpressure valve is set for 9 bar, the pump will put water in the coffee until it reaches 9 bar, and then the overpressure valve will open so the excess water will go through the overpressure valve and back into the water reservoir.
Okay.
Okay.
So those are those two separate.
That's the overpressure valve, the
steam pressure.
Steam pressure relief valve.
Okay.
And then also an overpressure valve is used in a similar way on a dual boiler machine. And many commercial machines have this. So in a brew boiler, you have water filled completely in the boiler, and as it heats, it expands, so it has nowhere to go. And if there was no relief in that, it would just expand and actually blow the boiler. Essentially cause a leak somewhere. So they have a overpressure valve for those, which is usually set to 10 or 12 bar, and that allows for the water to expand. And if it gets too great, it just drips a little bit of water out into the drain box, and it keeps the pressure at a manageable level under 12 bar usually. Okay.
So we sometimes see the machines will have a little kind of spigot on the side or something.
Exactly, that kind of drips every once in a while.
And that's what that is.
That's exactly what that is, right?
Okay, so you can have a machine that has that,
right?
But it doesn't necessarily have brew pressure release in the brew head.
Correct.
Okay, so what is that?
So brew pressure release in the brew head, not to be confused with all the other ones, is something that allows the pressure to be released from the portafilter after brewing, so you can immediately release or take out the portafilter when you're done. If you don't have a pressure relief valve, you have to wait for several seconds after you're done brewing to release that. Otherwise, there's still pressure in there, and it'll go squirt coffee all over. So the brew pressure relief valve can be accomplished two different ways. One, manually, like in this E61 group head we have here, or electronic version is this three-way electric valve or solenoid valve.
Okay.
And so let's see. Let's cover the E61 first. So we can consider this a three-way valve also, where water comes in here, it goes out here, so that's 1, 2, and then the delivery area is right in here, where the portafilter would go. here. So that's 1, 2, 3 positions for the valve. So we have intake, exhaust, and the coffee. So when water goes in, the exhaust valve closes. Water can go into the coffee. Then when you're done brewing, the intake valve closes. That stops the water flow. And the exhaust valve opens, which allows the excess pressure to be released down into the drain box. So then you can immediately take out the portafilter. It also helps just because when you're done brewing coffee, there's a little bit of slurry of water on the top of that that will also get channeled back down through the exhaust. So when you take it out, it's not so syrupy and a little easier to manage.
All right. So that's a mechanical.
So this is the mechanical 3-way valve. Intake, exhaust, and the coffee.
Okay.
All right. So in the other version, the electronic, we have what's called a 3-way valve. And I'll take it apart. This black thing I'm taking apart is the coil that has just a long string of wire that's wrapped around in a coil, and when that's energized, it creates a little magnetic field and pulls this piston up and closes off a port. So I'll go through this valve with you. If it was hooked up to a brew head, it would be, hold this together, it'd be hooked up something like this.
Okay. And that's the bottom of, that's
And
where your portafilter goes.
This is where the portafilter or the coffee is.
Okay.
So we have coffee here, we have an exhaust port up here, and we have intake port right here. So the water from the boiler would come through this valve up into this small area, and right now the valve is closed. The little piston here is sealing off this area, so no water can go into the boiler yet. But right now water can actually go out through this area and up through, there's a little slot in the side of this piston where water can go through, and it goes up into this area and exhausts out to the drain box.
Okay.
Now, when you turn on the valve, do this carefully so it doesn't all fall apart. When the valve gets energized, it pushes. Oh, there it goes. It pushes this piston up like this. Mm-hmm. So, you ever turn on the machine, you hear a big click. This is the click right there. I can't do it fast enough to make the loud click, but so you put it up, and there's a little seal on this end also that seals this port off. It closes that port, opens the water port that allows water to come in through the boiler, up through the valve, and down into the coffee right there, like that.
Okay.
So it'd be water comes in through here, up through this little area, down into the coffee. Then when you turn it off, the valve goes back down and allows water from the coffee to go back up through this valve and out through the exhaust port.
And that's managed through this electrical component.
Correct. So
Okay.
there's a switch either...
Now, Bill, why didn't you cut this in half?
Yeah. Oh, sorry. Next time.
I'm assuming there's some kind of electrocution that might happen.
There's just a lot of wires in here, and they don't cut in half very well. But
All right.
some other day we'll do that.
Okay. So that fits onto this.
So this valve goes like this, and then this coil fits over the top of the valve like that. So if you're looking at the valve, it would look more like this on this side.
Okay. And so you were saying that when you combine it together, that's when it's referred to as a solenoid valve?
Correct. So this is a coil, and this is a valve, and when you put these things together, it's called a solenoid when you use electromagnetic energy to move something back and forth.
And that can be used in all different kinds of formats, not just brew heads.
The solenoid is used in many places.
Okay.
So, some super automatics have solenoids to move little flappers. Your doorbell typically works on a solenoid to move a thing back and forth to ring the doorbells.
The plumbed or the convertible rockets use the solenoid to switch between tank and plumb.
Yeah,
they have
exactly.
a little switch. Okay. Cool. All right. So both of them achieve or are designed to do the same thing, which is to release that pressure there.
Correct. So both have the same exact function. They have a 3-way valve. There's an intake and exhaust, and then a port for the coffee. So that's 1,
Okay.
2, 3. And you turn them on, and it allows water to go in. You turn them off, and it allows water to go out.
All right. And the main purpose of that is so that, like, when you're removing that portafilter, you're not going to be at risk of, like, it exploding everywhere.
Exactly. It allows you to just take the portafilter off immediately. If you wait 10 or 15 seconds or 20 seconds, the pressure will go out anyway, and you could relieve the portafilter. But this allows you to do it immediately.
B, you have any questions?
Just stunned with all this endless knowledge. You know, are there any other negative things about not being able to do that other than immediately taking your portafilter off? Like the life of the machine, does it have any effects on that?
Not necessarily.
Okay.
The pressure isn't, I mean, depending on, who builds the components, of course, but for the typical state-of-the-art stuff that we're using right now, there's not much difference if it does it, if you have a three-way valve or not. The three-way valve is definitely more convenient to use as a machine, but otherwise, no.
Okay. And I guess it's nice to have dry pucks
Yes.
instead of scooping out the soup. Cool. All right. Any other questions, B?
I don't have any.
Okay. All right. Thank you very
All right,
much,
you're
Bill.
welcome.
Thank you, Bill.